Hey everybody, welcome back. This is section 1.2 for business calculus. And we're going to jump into something called composite functions. And this is where we take the domain of a function, put it into a function, we get a range value, but that range value, that output, becomes the new domain for a new function. And that's going to look like this. So if we're given two functions, f and g, then f composite g of x, this is the notation with a little circle in between. And this becomes f of g of x. And you can imagine it can get even more complicated where there's like 5 or 6 functions inside of one another and so on. But we're just going to stick with 2 for this course. We don't need any more than that. And what this means is we're going to have to work from the inside out, meaning we're going to have to evaluate, in the case of the example that I have above there, we're going to have to evaluate the g of x first. Meaning whatever value of x, I'm going to evaluate it in function g first, then whatever value I get for that, I'm going to plug that into function f. All right. So let's take our two functions, f of x equals 4x plus 9. Then we have g of x equals 8 minus x squared. And so we're going to start with part A, where f of g of x, or g of 0, I should say. And what I'm going to do is I'm going to evaluate the function g of x at, that's squared. This becomes, let's write that over here. F of, and this just becomes 8. So g of 0 just becomes 8. And now I'm going to take the function f of x, and I'm going to plug in 8 for x. And that is going to give me 41. And that is going to be my final answer. So that is f of g of 0. Now let's go the other way. And believe it or not, it's actually going to become a different answer. You may think that it should be the same, but it's actually not. So part B. So g of f of 0. So I'm going to evaluate the function f at 0. So that's going to be 4 times 0 plus 9. So that's going to be g of 9. So I'm going to go to the function g of x, and I'm going to go 8 minus 9 squared. And that is going to be my final answer there. Now, it probably looks a little weird, especially if you haven't seen this before. It's going to seem a little strange, but again, you want to work from the inside out. A common mistake is to try to work with the out, like for part A, to deal with the function f first, and you don't. You have to deal with the function g first, which is the inside one. All right, question 2, we have a table. X goes 0 through 9, and then we have a f of x, and we have the 6, the 2, the 9, and so on. And then we have a g of x, which has a different result. And so we're going to try to identify the composite function. And so I'm going to take, first of all, I'm going to look at the g of 2. I'm going to look there first. So I'm going to take g and evaluate it at 2. And that gives me 3. So this becomes f of 3. And what that means for us is I'm now going to take the function f, and I'm going to evaluate it at 3. And that's going to give me 8. And that actually is my actual answer. Let's try another one. All right, so f of 0 means I'm going to take f, evaluate at 0, that's going to give me my 6. And to be clear, this here, undo. And again, that becomes 6. And now what I'm going to do is I'm going to evaluate g, the function g, specifically when x equals 6. That's going to give me a result of 5. All right, let's do another one. So we're going to start with f of 5. It's going to be the function f, evaluated at 5. That's going to give me 0. This is going to be f of 0. And we are now going to go to f again, but evaluate it at 0, which is going to give me my 6. All right, we also have g of 9. So I'm going to focus on g of 9. G of 9, that gives me a 2. And now once again, I'm going to focus on g of x, but this time I'm going to go to when x equals 2, which is going to give me a value of 3. I know it can be a little overwhelming. You may need to rewatch the video a few times just to kind of piece together what's going on. Hang in there, though. We got this. All right, so we are going to composite two functions, and we have f of x equals 1 over x minus 4. G of x equals 7 over x plus 4. So I'm going to start over here with, in fact, I'm going to steal some space up here. F of g of x into f of, now g of x is 7 over x plus 4. And what I'm going to do is I'm going to take all of that, and I'm going to put that right there. I'm just going to substitute it right on in. This becomes 1 over 7 over x plus 4 minus 4. And you can see where I replace the x with the 7 over x plus 4. The good news is that I can see right away 4 minus 4 is 0. So this leaves me with 1 over 7 over x, which is just x over 7. Very nice. Now we're going to go the other way. What if we do g of f of x? And this time I'm going to evaluate f of x, and I'm going to replace this x here with all of this. Ooh, that looks very overwhelming. Let's see if we can clean that up a little bit. Now 1 over x minus 4 comes up to the numerator. And now I'm going to distribute the 7. 7x minus 28 plus 4. And that is my final answer. So there is a composite function, and we ended up with a function. Now you'll notice with these previous ones, we were evaluating them at specific numbers. we're now saying let's keep it general in terms of x. All right, now what we're being asked to do is we're trying to go backwards. They're saying the function h of x is x plus 7 raised to the 9th power can be expressed in the form f of g of x, where f of x is x to the 9th. This means g of x has to be, I want to point out, it's going to be that. It's going to be this. So g of x has to be the x plus 7. And you'll note f of g of x is f of now x plus 7 is what I'm claiming, which means, oops, 7, not 5. And you can see that is our h of x. So again, they're trying to have us work a little bit backwards. All right, question 5. The function d of p gives the number of items that will be demanded when the price is p. The production cost, c of x, is the cost of producing x items. Determine the cost of production when the price is $8. You would, now we're given a lot of craziness here. Now keep in mind, what we are looking for, and I'm going to highlight this, what we are looking for is the cost of production. That is going to be the first part. So that is either going to be here or here. Because C comes first, because we're looking for the cost of production. So when the price is 8, now remember, P is the price, and we have D of P. So this means D of 8, or the cost when the demand is at the price of $8. So this is going to be our answer here. Once again, D of P, P is 8, so D of 8 is what we're going to have. But overall, we're looking for the cost when the price is 8. So that's going to be the cost of the demand of $8. I know, it's a little weird. We're now going to do something called translations of functions. And we're going to have a function of the form something to this effect. We are not going to be interested in the a in front at this point. We are only interested in the h and the k. Now, I want to point out it's x minus h. That means the x coordinate has to be the opposite sign. The k, though, is plus k, so that's going to be the same sign. Here's what this means. If we want to take this function and shift it up 1, this is going to be, I'm going to call this f sub 1 of x, just so it's a little bit different. 3 root x, and that's going to be plus 1 on the outside. Now, again, up and down, it's the same sign, SIGN, meaning it's positive 1. Now, if I want to go up 1 and right 4, now the 4 has to be the opposite sign. Now, to the right means that it's going to be x minus 4. Now, again, that may seem counterintuitive, but the x coordinate has to be exactly the right. So right is in the positive direction, so it's going to be x minus 4. So for this particular example, it wants to be right 4 and up 1. So this is going to be the graph here. And that all comes back to our basic graph. If we go back to our, oh, that's from section 1, pardon me. But if you look back at section 1, y equals root x is that same graph, but this time we're starting at 4 and we're going up 1. But notice once again, it's x minus 4, even though we move in the positive x direction. We move to the right. So let me just reemphasize, this is going to be 3 square root x minus 4 plus 1. When you're writing it like this, make sure that your radical doesn't kind of look like it goes over the 1 or not, right? Make sure it's very, very clear that that 1 is definitely not under the radical. Once again, that is our answer for this problem here. All right, we're going to do some more. Again, remember the x direction, left and right. Left means plus, right means minus. The y direction, up means plus, down means minus. All right, here's another one. If you remember, the original graph started at the origin, and this was the line y equals x. If you remember, it looked like this. But now what we've done is we've moved it to the right 2 and up 3. If you remember the original function was absolute value of x. And again, actually, let me do this. Let me color code it. That was this one here. But now we've moved it. So our function here, our black function, f of x, it went to the right 2. So that's going to be x minus 2. Remember, it's the opposite sign. But in the y direction, we went a positive 3. And that is going to be our graph there. Again, we went to the right 2, which means it's minus 2, opposite sign in the x direction. Or what we, that point is called the vertex. All right, so this function that was our original function, again, let's color code that. Our original function, f of x equals x squared, looked like this. But we have moved the vertex a positive 1 and down 1. And what that means for us, and by the way, notice this is pointing downward, not upward, which means that lead front part is going to be a negative value. So this is going to be, I'll call this g of x. And we moved x in the right direction. Again, that's going to be x minus 1 squared. And we went down 1 in the y direction. And because it's pointing downward, we need to have a negative in front. So this is going to be negative x minus 1 squared minus 1. Now, if it was pointing upward, then it would be a positive x minus 1 squared. But it's not. And that is going to do it for this lesson. Hope that helps, and I hope that you are successful.